Hey VC Math students, I hope you are having a great day. Welcome to another video of hok'stutoring. Today, we'll be going through a tutorial video of chapter 10b, question 17. So this is your application of differentiation chapter, and it's the very last question of that subtopic of 10b, question 17. So without further ado guys, let's get into the video, into the question. So 17, the mass m kilograms of a radioactive lead remaining in a sample t hours after observations began is given by m equals to 2e to the power of negative 0.2 t. And then you've got 4 sub-questions. A, find the mass left after 12 hours, and then we'll read along B, C, and D after we solve these questions. So, in question 17, and generally again, as I repeat with all my other videos, with any application type questions, you want to always be able to visualize, a graph or maybe a diagram or just some kind of visualization that can help you, solve this question, or just to help you, understand what the question is. So essentially, if I was to, sketch this on a graph roughly, I know my y is essentially my m, and then my x-axis is essentially my time, and it's basically saying that yes, I've got a mass of lead initially somewhere, but then over time it's either decays or something happens to the mass. And just judging by this exponential equation, over here, so exponential looks like this typically, but because there's a negative over here, at the power, there's a reflection in the y-axis. So this graph then turns into this graph. So your rate of decay, we don't know what it's like, but potentially it's it might look something like that, or it might look, it just looks something like this. Okay, it's decreasing over time. That's all we need to know. And then let's answer the question. So in 17a, this is generally your free mark. Find the mass left after 12 hours. So what you can do here is sub t equals to 12. Just make sure that t is in terms of hours. In this case, yes, t is to hours, because sometimes it could be a trick question where t is in terms of minutes. And in that case, you can't sub in t equals 12. You have to sub in t equals 12 times 60 so that you're subbing in the appropriate number. So just be careful, read the question properly. No trick in this case. 2e to the power of negative 0.2 times by 12, and obviously chuck into your calculator. You should get a mass of 0.18 kilograms. Okay. So that's it for part A. Free mark, 1 mark, easy, done. Get it done. Get your free mark. And then part B, it says find how long it takes for the mass to fall to half of its value at t equals to 0. Ooh. So there's essentially a couple of ways of doing this question. The simplest one that comes to mind is, well, what is the mass at t equals to 0? So you sub that in. So m0 equals to 2e to the power of negative 0.2 times by 0. And what you get is e to the power of, 0, because that's what this gets you. E to the power of 0, you get 1. 1 times 2 is just 2 kilograms. So half of 2 kilograms is just 1 kilogram, so you can just sub that in into the equation again. So m equals to 1. And then solve for t, right? Because that's essentially the question. You have m equals to 1, which is half of 2 kilograms, which is the number of, which is essentially the mass that the lead started with, or the observation started with. And then you solve for t, and you get t equals to 3.47 hours, okay, on your calculator. So the good thing about this question, and what I want to show you more so than just solving it this way, is that number 2 right there. Actually, that could be any number. So a thing that I've seen creeping up in recent exams is they would give you an equation very similar to this, but instead of putting a number 2, they'll put a, okay, e negative 0.2t, something like that. And then they'll just ask you, find how long it takes for the mass to fall to half of its value at t equals 0. So a lot of students then, they don't have a number here, because when you solve for this, you just get m equals to, you sub in 0, you get a times 1, you get a, right? So at m0, you get m equals, you can get just a. And then students thinking, that's not a number. How do I solve for this to find half? Well, it's very simple. Just literally half a, okay? If you half a, what you get is this equation over here. And the good thing with this is the a actually cancels out, because to solve for t, you have to divide both sides by a, right? And the a cancels out, and you're left with half equals to e to the power of negative 0.2t. And then there we go, your a completely disappears and you solve the equation, and what you get is the same answer. T equals to 3.47 hours. So it's very smart. You can actually ignore that number. You don't actually even need to start with that 2 kilograms to begin. You don't actually even need to find m0, right? You can immediately just ignore a and just go straight and say, yep, e to the power of negative 0.2t equals to half if I want half. And if they want quarter, then you can say, yes, I just need a quarter. And if they want 1/8, which is actually exactly what part C is talking about, is you can just sub in 1/8 over here and it completely just ignore A, because you know at the end of the day they'll cancel each other out, just as what I've shown you here. So that's a bit of a shortcut and also something to take note for your exam and for your SAC. So guys, let's actually take advantage of that and solve for part C. Part C is asking you, find how long it takes for the mass to fall to 1/4 and 1/8 of its value at t equals 0. So doing exactly what we've just done here, ignore the a, ignore the 2, you can just say, yes, e to the power of negative 0.2t equals to a quarter, and then e to the power of negative 0.2t equals to an 8, and then just solve for t on your calculator. So it kind of reduces, I guess, the number working out. If it's just a 1 mark question, literally just solve for it quickly, just like that. So for the first one, you get 6.93 hours, and for the second one, you get 10.4 hours if you solve for t. Okay, so that is part C, and then let's do the last part, which is part D. It's asking, short question, express the rate of decay as a function of m. So m is a equals to 2e to the power of negative 0.2t. m equals to 2e to the power of negative 0.2t, and they're asking you for the rate of decay, which means the gradient, essentially the rate of change. And if you were to differentiate this, you differentiate the power, you get negative 0.2, multiply that by 2 in the front, and you get negative 0.4 e to the power of negative 0.2t. And you might think, yes, a lot of students might think that, yes, this is it, that's my final answer, get my mark, and I'm done. But just read the question carefully. It is saying as a function of m, not a function of t, which is generally what the question would ask you for simpler ones, but this is a function of m. So our equation here is a function of t at the moment, right? It's not a function of m yet. But the good thing with exponential is, remember, the exponential stays as it is even after you differentiate. So if I want to turn this, into a function of m, right? So how can I write this in terms of m? Well, m is 2e to the power of negative 0.2t. Very similar format to this already. You just need to manipulate the numbers a little bit, so that you can, get it so that's in terms of m. So the e to the power of negative 0.2t is good. But what can you change to negative 0.4 so that you have 2e negative 0.2t here, which is m. We know that you can actually substitute m into over here, but then we can't lose that. It's originally negative 0.4. How can I get it so that negative 0.4 becomes, 2e to the power of negative 0.2t? Well, if we know we need a 2 here, what can we multiply the 2 by to get negative 0.4? You can multiply it by negative 0.2, right? Negative 0.2 times 2 is negative 0.4, and you end up with, your original differentiated question or equation. And in this case, we know that this function right here is in fact m, because that's exactly what m is, 2e to the power of negative 0.2t, and dm dt is equals to negative 0.2 m. So now it's in terms of m, which is great. That's exactly what you want. And to finish answering the question, the rate of decay, so that's what they're saying, rate of decay is, no, and the answer to this question is a bit tricky because the rate of decay is in fact 0.2 m. So some students might think, yes, it's negative 0.2 m because, that's exactly what I got, right? But just be careful, the rate of decay, because the word decay here means it's already decreasing. So generally you can write 0.2 m because it's already decreasing. You don't need to include the negative because we know negative means it's decreasing already. So you can ignore the negative. So that's pretty much the answer that you can write. It's also the answer in the textbook. For me, generally, if I try to keep it safe, I would say rate of decay is dm dt equals to negative 0.2 m. That's my safe way of writing this, as that's generally going to guarantee you the marks. But guys, that's pretty much it for the video. This one's a quick and nice one. Question 17 of chapter 10b. I hope you found it useful. And if you did like the video, please leave a like and subscribe to hok'stutoring YouTube channel, because I would greatly appreciate that. Thank you for watching, and if you have any other questions, please leave a comment down in the comment section below. I would have a read and then I'll get to it. Thanks for watching, and I'll see you in the next video.